This is Physics Chapter 2, Problem 76, and 76 reads, a Thomson's gazelle can run at very high speeds, but its acceleration is relatively modest. A reasonable model for the sprint of a gazelle assumes an acceleration of 4.2 meters per second squared for 6.5 seconds, after which the gazelle continues at a steady speed. So part A is asking, what is the gazelle's top speed? So we can find its top speed by using this equation. Velocity final equals velocity initial plus acceleration times time, because it gives us our acceleration and our time. So we just need to plug in our values from here. So our initial velocity is 0, it's starting out at 0, and our acceleration, it gives us 4.2 meters per second squared, and we multiply that by our time, which was 6.5 seconds. When you multiply those, your velocity final should come out to 27.3 meters per second. Part B is asking us, a human would win a very short race with the gazelle. The best time for a 30-meter sprint for a human runner is 3.6 seconds. How much time would the gazelle take for a 30-meter race? So to find that, we can just use this equation. X final equals x initial plus velocity initial times time plus 1/2 times our acceleration times our time squared. So we need to find our final x, so we just plug in our values. Again, our x initial is 0, and our velocity initial is 0, so that when you multiply that, it just comes out as 0. And then you can just plug in our acceleration, which was 4.2, times our time, which was 6.5. You gotta square your time. And so that should equal 89.7 meters. So using 89.7, we need to still solve for how long it's gonna take it to run a 30-meter race. So we have our x final, which is 89.7. And then our x initial and our velocity initial times our time is 0. And so that just leaves us with 1/2 times 4.2, and then we don't know our time, so our time's squared. So when you solve for that, you should get 30 over 2.1. And so you have to square root that to find just t, and that should be the square root of 14.3, which is just 3.78 seconds. And so for C now, you have to find, so it says a gazelle would win a longer race. The best time for a 200-meter sprint for a human runner is 19.3 seconds. How much would the gazelle take for a 200-meter race? So we can so the distance we got here, we have to subtract from the 200 meters it's running. So we do 200 minus 89.7, and that should give us 110 meters. So to find our time, we can use the velocity equals displacement over time. And so we can solve, so when you solve for t, it's just our d over velocity, and so then that gives us 110 meters over 27.3, which we found here, and then that should give you 4.02 seconds. That's how long it's going to take it to run 110. So you just need to add the time you got, the time it takes it to run here, and then add it to this. So it's 6.5 plus 4.02, and that should give you 2.5 seconds.